Hello everyone, welcome to your geometry video lesson. Today we are going to be working on kites and trapezoids. If at any point you need to repeat anything, you can always play back a certain section, or you can just pause the video and take some time to copy down what's going on. So right now I want everyone to copy the objective. We are going to use properties of kites and trapezoids to solve for missing sides and angles. Now, a kite is a quadrilateral with two pairs of adjacent congruent sides and no opposite sides are congruent. We'll have different quadrilaterals for that later on. One cool thing is that the diagonals of a kite are perpendicular to one another. And of course, if you remember what perpendicular means, that means they create right angles. Now, the longer diagonal bisects the shorter diagonal, and the longer diagonal is also an angle bisector. It bisects the top and bottom angles. So with all this information, we can go ahead and mark our diagram. So right here we're going to draw our first diagonal, the shorter diagonal, and then going up and down we're going to draw our longer diagonal. So the first thing we said about the diagonal is that they're perpendicular. So let's go ahead and draw in right angle marks. Now I know I put 2 there, but all 4 of those angles in the middle are right angles. The other thing we noted is that the long diagonal bisects our shorter ones, so we can make some markings on the shorter ones. We say that those 2 parts are congruent now. They are equal in length. And then of course the top and bottom angles are both split in half. So we can put our angle marking up here, and then we can also put them down below. So your diagram should somewhat look something like this. You don't always have to make these markings, but just know that these properties will be used when we need to solve for a missing side or angle. So let's go ahead and move on to our first example. We wish to find the lengths of our sides in this kite. So the first thing I'm going to want to do is go ahead and mark what I know for sure is congruent. These 2 sides are congruent, as well as these 2 sides. So now I'm also going to mark and set up some equations here. So I'm going to say 2x plus 4 equals 3x minus 5. Now, I've taught you all before that it doesn't matter how you solve it, as long as you get all the x's to one side and all the constants to the right side. Now, it doesn't really matter, per se, the side, but notice that my 3x is bigger than my 2x. So what that will allow me to do is say, hey, I don't want to worry about negatives, so I'm going to move the smaller variable over. So now I have 4 equals x minus 5. And now I need to get that x isolated. So let's add 5 to both sides. So what we will be left with is 9 equals x, or just x equals 9. Now let's go back to the other equation that we didn't set up yet, but we're going to work with. X plus 6 equals 2y plus 5. I have a problem here. I have mixed variables. Can't solve it on its own. However, remember we did solve for x earlier. So let's substitute in the value. Alright, so now we're just going to keep working our way through combine the like terms, and now we're back to our Algebra 1 land. We're going to go and do a two-step equation. As I say 2, I write a 2. Don't do that. That's bad. Now I need to get y by itself. The 2 is being multiplied in front, so I need to do the operation that is going to cancel out the 2, which will be dividing by 2. So then we are left with y equals 5. And that's your first example. Go ahead and give example 2 a try, and by example 2 I mean letter B a try. I'm going to wait for you guys to give it a try, not too long. My sub will pause the video right here. Alright, so for this one, remember that we said that the longer diagonal bisects the shorter diagonal. So that means that this and this are congruent. So we can solve for x right there. So again, same thing, move the smaller variable to the other side. That way you don't have to worry about negatives. And then from here, right back to algebra land. So then going on to solve for y, we're still going to do the same setup. These two parts are congruent. So that means that these two segments and these equations are congruent. So again, go on through and solve it. I'm going to skip an extra step, but again, if you need to show all the work, by all means do so. I'm going to take care of the y's as well as the 15s. So then these two are gone, these two are gone. So all I will be left with is 2y equals 20. Divide by 2, y equals 10. So those are some of the types of problems you can work with. Now let's talk about the angles. So right away, I know that the intersection of my diagonals creates a perpendicular angle, which means that angle 1 and angle 3 are both going to equal 90 degrees. That's not something that you necessarily have to show a lot of work for, but just know that fact. Next, take a look at this right here. This whole triangle here, where angles 3 and 2 and 64 degrees are, they all have to add up to 180. So, since we know angle 3, we could say 90 plus 64 plus angle 2 equals 180. I'll fix that angle 2 so that it doesn't look like an L2. There we go. So then combine the like terms. 154 plus angle 2 equals 180. Take away that 154. So then you should have angle 2 equal 26. Oh wait, 26 degrees. Alright, so use those properties. Take a look at the chart above and try to solve this second part of example 2 on your own. Alright, so again, we're going to look at the intersection of our diagonals, and we're going to notice, hey, angles 1, 2, 3, and 4 all form right angles. So we know that they are all going to equal 90 degrees. Next, I'm going to look at my last property that I had listed, which said that the longer diagonal bisects the top and bottom angle. So what those two angles will be are these angles here and these angles here. So what happens is that each side is now congruent. So we can say angle 5 is congruent or equals 26 degrees. Angle 6 is 44 degrees. Now we can go through and we can work with the two different triangles that are up there to solve angles 9 and 10. Now I do want to point out something. Not only are they triangles, so we can worry about the 180 minus the other angles, I also want to point out that in a kite, they reflect. So there are two equal halves. So once I solve for angle 10, I also know the value of angle 8. And likewise, if I solve for the value of angle 9, I will know the value of angle 7. So again, angle 3 is 90 degrees. Add that with 26, plus angle 10. So we have angle 10 is 64 degrees, which also means that angle 8 is 64 degrees. Now going on with the other triangle for angle 9, we know that 44 plus the 90 plus angle 9 all add up to 180. So then angle 9 will equal 46 degrees, and angle 7 will also equal 46 degrees. So all these video clips are limited to 15 minutes apiece, so I'm going to go ahead and make another video for the back page of your notes.